Good morning, students. Today we will start with the new chapter. So the chapter name is Nuclei. Right. So for board exam from this chapter we have 6 marks. So out of 6 marks, one question will come for 1 marks and one question for 5 marks. So here also in 5 marks, the possibility of asking theory or numerical. So from this chapter, numerical is very important. So this year also they asked the numerical problem from this chapter for 5 marks, right? So this is about the weightage of the chapter nuclei, right? So this chapter is for 6 marks, and from the 6 marks, one question will come for 1 marks and one question for 5 marks. So in the 5 marks we have derivations along with the numerical problems, right? So as of we already studied in the last chapter, that is in autumn, we almost studied the nucleus. That is, so in autumn, the maximum mass are concentrated to a small volume, that is positive charge, which is concentrated to the small volume. So that we call that one as the nucleus, and the electron which is revolving around the nucleus, right? So this one is the electron, right? So this overall we call as the atom. So entire mass of the atom which is concentrated to a small volume, that is densely concentrated. So that volume we call as the nucleus, and nucleus is positively charged. So electron is revolving around the nucleus, right? So along with that, one experiment from alpha scattering experiment. So by the alpha scattering experiment, we discussed that the radius of the nucleus is very small compared to that of the size of the atom of the order of 10 to the power of 4, right? So that is, the radius of the nucleus is very small than that of the radius of the atom. Of which order it is? So it is of the order 10 to the power of 4. So that means its value is 10,000 times smaller than the size of the atom, right? So along with that, volume of the nucleus, right? So it is, the atom is in spherical shape, then the nucleus is also in spherical shape, right? So here the volume of the nucleus is very less than the volume of the atom. So that is of the order 10 to the power of minus 12 times less than volume of atom, right? So these are all we discussed in the last chapter in atom. So from those we find that the nucleus is positively charged and the radius of the nucleus is very less than that of the radius of the atom, that is of the order 10 to the power of 4, right? So along with that, the volume of the nucleus is 10 to the power of minus 12 times. That means its value is 1 divided by 10 to the power of 12. So 1 is equal to the 12 zeros, right? So that much lesser than that of the volume of the atom, right? So in this chapter we are only concentrating on this nucleus, right? So in this chapter we are going to study the characteristics of the nucleus or properties of the nucleus, right? So that's why the chapter name is given as nucleus. So here in this chapter we are studying the topics, that is characteristics or properties. So that one is, in that first one is mass of the nucleus. So next, second one is size of the nucleus, and the third one is stability of the nucleus. So these are the properties which we are going to study in the chapter nuclei, right? So along with them we have nuclear phenomena. right? So one more topic in this we are going to study is nuclear phenomena. So in this nuclear phenomena, we are going to study the radioactivity, and nuclear reactions. So in this nuclear reactions, we have two. One is fission and another one is fusion. Right? So this is the overview of the chapter nuclear. So from all these topics, we are covering for 6 marks. Right? So that is the characteristics of the nuclei or properties of the nuclei. In that first one is mass, next size and stability of the nucleus along with the nuclear phenomena. So in this nuclear phenomena, the first phenomena is radioactivity and the second one is the nuclear reaction. Right? So in nuclear reaction we have two. One is fission and another one is fusion. Right? So this is the overview of the chapter nuclei. Right? So next start with the mass, right? So that is atomic mass along with its nuclear composition. Atomic mass and nuclear composition, right? So as of already we studied, the size of the atom or mass of the atom is very small, right? So the mass of atom is very small compared to kg, that is compared to kilogram, right? So if we take one example for mass of the carbon 12, that is C12, right? So the mass of carbon 12 we have 1.992647 into 10 to the power of minus 26 kg, right? So this is the mass of the carbon 12, right? So that mass is how much here? 1.99 into approximately it is 2 into 10 to the power of minus 26. So if you observe here, minus 26 is very smaller value compared to that of the kilogram, right? So this value is 1 divided by 10 to the power of 26, right? So this value is 0.000 up to 26 zeros. After that we get this numerical value, right? So this value is very small compared to that of the kg. Hence for measuring the mass of the nucleus or mass of the atom is not convenient by measuring in terms of kg, right? So that's why we are going to use the new mass system to measure the mass of the atom. So that one we call as atomic mass unit, right? So it is denoted by U. Initially we are mentioning this one as AMU, so here we are going to use only U, right? That is atomic mass unit. Why we are going to use this unit means this value of the masses of the atom is very small compared to that of the kilogram, right? So it is not convenient to measure the masses of any atoms in terms of kg. For every time we need to write into 10 to the power of minus 6 into 10 to the power of minus 27, like that, right? So for that reason we are going to change the system of unit from kg to which one it is? That is atomic mass unit, right? So that one is denoted by U, right? So atomic mass unit is defined as, it is value, the atomic mass unit is defined as 1 by 12 to the, that is 1 divided by 12 into mass of the carbon 12 atom. Mass of carbon 12, that is C12, right? So this gives the atomic mass unit. So if we define the atomic mass unit means, so atomic mass unit is defined as 1 by 12 to the mass of carbon 12 atom, right? So 1 atomic mass unit U, that is equals to, as we already know the value of mass of carbon, that is 1.992647 into 10 to the power of minus 26 divided by 12, right? So then here we get 1 atomic mass unit U is equals to 1 divided by 99, we get 1.66, that value is 1.660539 into 10 to the power of minus 27 kg, right? So this is the 1 atomic mass unit, right? So 1 atomic mass unit value is how much? 1.660539 into 10 to the power of minus 27 kg, right? So if any value having this much value, then we call that one simply as 1 atomic mass unit, right? So for example, the mass of chlorine atom is 35.46 U, right? We can, in the easiest form, we can write like this: the mass of the chlorine atom is 35.46. Now if we observe here, mass of the carbon, here we are measuring in terms of kg, it gives the larger numbers, right? So 1.992647 into 10 to the power of minus 26 kg. So we need to complicate the value like this by reducing by the unit, that is atomic mass unit, right? So now if I write the mass of chlorine, we get the mass of chlorine atom is 35.46 am, right? So this is basic about the mass of the atom. So the unit which we are going to use the mass of the atom is atomic mass unit, and its value is how much? 1.660539 into 10 to the power of minus 27 kg, right? So example for that one is mass of chlorine is 35.46 am or 35.46 U, right? Now if we measure the mass of the chlorine atom by using the mass spectroscopy, that is accurately if we measure the mass of the chlorine, then here we observe so here if we consider this one as one chlorine element, so chlorine element consists of the chlorine atoms which have the same properties which has the element as, right? So if we consider this one as chlorine, right? So if we measure the mass of the chlorine, so this element consists of atoms of chlorine atoms, right? So these are the chlorine atoms and this is the chlorine element, right? So if we measure this chlorine atoms by using the mass spectroscopy, if we measure the chlorine atoms, so these atoms has different masses, right? So if we consider this one as atom 1 and this one as atom 2, so these atoms have different masses, but these atoms has the same chemical properties, right? So the atoms which are present in the chlorine atom which has different masses and it has the different masses, that is atoms which are present in this chlorine has different masses, and these atoms exhibits the same chemical properties, right? So we have the value of the mass of chlorine is 35.46, that is mass of the chlorine atom. But here each atom exhibits the different masses. When we observe the through the mass spectroscopy, if we measure the masses of the atoms in the chlorine element, so each atom exhibits the different masses, but different masses along with the same chemical properties, right? So the atom species which have the different masses in the same element, then those are called as isotopes. So they given the name as isotopes. So what are isotopes? So any element which having the different masses, then those are called as isotope, right? So any element, either it may be chlorine or it may be hydrogen. So any element which having the same, that is in the same element which have different masses, right? So that one we call as the isotopes, right? So if you write the definition of the isotope, atomic species of element having different masses, right? So for that we given the name called as isotope. So what are isotopes means? Any element which consists of atoms, but each atoms having different masses. So in the simple word we call that one as isotopes, right? So here in chlorine we have two types of masses, that is two types of the atoms which having the same masses, right? So one having the mass, so certain atoms having the mass, that is 34.98 U, right? So certain atoms which are present in this chlorine has the mass, that is 34.98 U, and certain having the mass 36.98 U, right? So that means this chlorine atom has how many isotopes here? So in chlorine we have two isotopes, right? So understand this one. So this chlorine consists of number of atoms. So each number of atoms possess the different masses, right? So certain atoms possess the mass is 34.98 U, and the remaining atoms possess the mass 36.98 U. That means it has two masses. So in this chlorine element we have two masses, so that's why we call that one as two isotopes, because the single element which having two different masses. So one mass is 34.98 and another mass is 36.98, right? So now how much quantity of the mass, that is atoms which are present having the mass 34.98, that is relative abundance of the atoms present in the chlorine atom of mass having 34.98 is 75.4%, right? So here we have number of atoms, right? So out of these number of atoms, how many quantity? So how much percentage having this mass, right? So that means up to here, that means out of 100%, 75% of atoms having the mass 34.98, right? So understand that one. So that is the relative abundance. So relative abundance of the atoms having the masses 34.98 is how much? 75.4%. So remaining atoms which have the mass 36.98 is how much? Here we have 24.6%, right? So this much of the atoms which having the mass 36.98 and remaining this much of the atoms which having the mass 34.98, right? Now if we measure the average mass of this chlorine, right? So average mass of this chlorine if we measure the average mass of chlorine is finding by multiplying these two values, that is this much of mass is present in how much percentage? 75.4 percentage. So this much of mass present in how much percentage? 24.6 percentage, that is 34.98 into 75.4 plus 36.98 into 24.6. This is whole divided by 2. Average is sum of 2 divided by 2. Right? So if we need to find the average of these two means, so this one part 1 plus part 2 whole divided by 2. So this much of atoms, that is 75% of atoms having the mass 34.98 and the 24 percentage of the atoms having the mass 36.98, right? So if we simplify, so we get 35.46 right? So that is we taken here. The mass of chlorine is the average mass of these two isotopes. So in general we written like this, that is 35.46 U, that is atomic mass unit, right? So understand this one. So any element which consists of several number of atoms, so out of those atoms which having the different masses, either it may be 2 kinds of masses, or it may be 3 kinds of masses, or it may be 10 kinds of masses which are present in the same element, right? So which possess the same chemical properties but different masses, right? So any atomic species which having the same chemical properties and different mass, that one we call as isotope. So here we taken chlorine as example. So in chlorine we have two isotopes, nothing but the chlorine which contain the atoms having two different types of masses. So one having the mass 34.98 and another having the mass 36.98. So the 34.98 mass of the chlorine atom is of the relative abundance is how much? 75.4 percentage, and 36.98 of the masses having the percentage 24.6 percentage, right? So if we calculate the average mass of the chlorine, we get the same value as we taken in the starting, right? So here the important one is isotopes. So what are isotopes? The elements which having different masses than those we call as isotopes, right? So if we take one more example, that is simplest element. So which is the simplest element means hydrogen is the simplest element. So in hydrogen also we are obtaining the isotopes. So in hydrogen we have 3 different types of masses. So those are called as isotopes of the hydrogen, right? So for hydrogen, right? So if you consider this one as the hydrogen element, so this hydrogen elements consist of atoms. So atoms having the different masses, right? So here it consists of 99.8925 percentage of the atoms having the masses, right? So one type of the masses which having the mass, that is 0.078. So it having the atoms of different masses. So in that first one is 1.0078 U, right? So next another type. So this one is the second type of atoms which having the masses, right? So the second type of the atoms having the masses 2.000141 U, right? So this one is the second type, and the third type is 3. So this, if you consider here, this one is the third type of the atoms which having the masses, that is 3.0160 U, right? So hydrogen is the simplest atom. So this hydrogen element is also having the three different masses, right? So of 1.0078, 2.0141, and the third type is 3.0160, right? So this much of percentage of atoms having the mass 1.0078, right? So hence this one we call as proton, right? So the maximum percentage of the mass of the hydrogen atom is how much? 1.0078 atomic mass unit, right? So the second type is 2.014, and the third type having the mass 3.0160, right? So for calling this one as deuterium and calling this one as tritium, right? So here this tritium is unstable in nature. So this tritium is unstable in nature. So hence it is not directly exist, right? So this can be obtained by in the laboratories, right? So this is unstable in nature. That is, tritium is unstable in nature. So hence it is naturally it will not exist. So this can be obtained in laboratories, right? So here the main is proton. So hydrogen which having the mass, that is 1.0078, that one has the maximum relative abundance, that is how much percentage? 99.925 percentage. Then so this one is the proton. So this becomes the nucleus of the atom, right? So if this is the nucleus and here we have the electron is revolving around the nucleus, means so this nucleus we calling that one as proton, right? Because it has always the unit charge, that is 1, right? So the mass of the nucleus is 1.0078 in the hydrogen atom. So the nucleus is always called as proton, and its mass is how much? That is 1.0078. It is nearer to the value of the mass of the hydrogen, right? So the mass of the proton is almost approximately equals to the mass of the hydrogen, right? So hydrogen having the mass, that is mass of the nucleus plus mass of the electron, right? So here if we consider this one as the nucleus of the hydrogen, we have 1.0078, right? So plus mass of the electron is 0.0055 U, right? So if we add, we get the mass of the hydrogen, right? So that is approximately equals to the mass of the proton, right? So if we consider any nucleus means, so that nucleus we call as proton, right? So it having the charge, that is charge is always 1, right? So this is the hydrogen atom. So hydrogen having 3 isotopes. right? So three isotopes we have, calling first one as proton, second one is deuterium, and third one is tritium. So tritium is unstable in nature, so this is naturally it will not exist. So this can be obtained in the laboratory. That is, it can be developed in the laboratories, right? So for considering, we discussed the atomic mass by considering two examples. So one is chlorine. So in chlorine we have two isotopes, and the simplest atom is the hydrogen. So in hydrogen we have three isotopes. So the maximum abundance of the hydrogen atom of 99.925% is proton. So hence the nucleus we call as proton, right? So as already discussed, the electron is which is revolving around the nucleus, and the atom is electrically neutral, right? So in the last chapter we discussed atom is electrically neutral, right? So then the charge of the electron, so charge of the electron is written as minus Ze, where Z is the atomic number and E is the charge of the electron, right? So hence the atom is electrically neutral. Then we can take the charge of the nucleus as plus Ze, right? Where Z is the atomic number. So where Z is the atomic number, right? So that is equals to the proton, right? So this is about the atomic mass. So we have discussed the two examples, one is chlorine and another one is hydrogen. So in hydrogen we have three isotopes, and as already discussed, the atom is electrically neutral. So we have taken the charge of the electron as Ze, where Z is the atomic number. To balance that one, we are going to take the charge of the nucleus as plus Ze. So plus Ze minus Ze, that is used to 0. So that means neutral. So the atom is neutral, right? So next, along with this, next one is discovery of the neutron. So where proton is electrically neutral, right? So next, that is the charged particle. So next one is discovery of neutron, right? So again we are going to consider the hydrogen atom. So in a hydrogen atom we having three isotopes, right? So hydrogen, which consists of the three different masses, right? So in that first one we taken that one as the proton, that is the masses of the hydrogen are in the ratio 1:2:3, right? So the mass of the proton is 1.0076. So mass of the deuterium is 2.014, and the mass of the tritium is 3.0160, right? So if we taken the ratios of the mass, we get 1:2:3, right? So considering hydrogen atom having the three isotopes, so for first one, if we consider this one as the nucleus, so electron is revolving around the nucleus, right? So here the mass of the electron is how much? That is in the ratio 1, that is 1.0072 something U, right? So that gives the mass of the nucleus, right? So this is the nucleus and we call this one as the proton, right? So for the next isotope, that is, this is for the hydrogen, that is for the proton. So next, the second one we are considering for the deuterium. So this becomes the nucleus and the electron is revolving around the nucleus, right? So here the mass is how much? 1% of the mass is proton, right? So here we have mass ratio is 1. So here we have 2, that is 2 point something. So here some mass is obtained by the proton here. So in the next case, if we taken for the deuterium, so its mass ratio is 3. So in that first we already know the first one is what? Proton, right? So we have proton here and we have proton here, right? So the hydrogen atom having the nucleus, that value is the maximum abundance of 99%, hence that one we call as the proton. The nucleus of the atom we call as the proton here. So here also proton and here also, right? So these are in the 1 ratio, right? So if you observe here, the remaining one part is there, right? The extra mass is present in the deuterium. So we don't know how the extra mass will be obtained in this nucleus, right? So here we have the proton value 1. So here we have the total value is 2. So then the relative mass ratio, if we write in terms of proton, then here we getting 1 here. Because proton having the mass is how much? 1, right? So 1 plus 1 we get here 2, right? So if we write the relative mass ratio, here we are getting 1. And now if you observe here we have the proton value of mass is 1 U, right? So here we have the total mass of the deuterium is how much? 3. So here we don't know the other remaining mass, right? So other remaining mass is how much here? Here is 1 and here is 1. So here we get 2, right? So the relative mass ratio is how much here? From these two is 1:2. So we don't know the masses of 1 and here we don't know the masses of 2 because we already know we have only the proton, right? So to find this unknown mass, James Chadwick conducted an experiment. So here one unknown mass is there and here we have 2 unknown mass is there, right? So for that, James Chadwick conducted an experiment, that is, he considered the nucleus of beryllium atom bombarded with the alpha particle. Nucleus of beryllium atom is bombarded with alpha particle. So here the alpha particle is the nucleus of the helium atom, right? So to find the unknown masses which are present in the nucleus of the hydrogen atom, that is in the deuterium and in the tritium, right? So for that, James Chadwick conducted an experiment, that is, he bombarded the beryllium nucleus with the alpha particle, right? So when the beryllium nucleus is bombarded with the alpha particle, then the radiations are emitted. So those radiations are the neutral radiations, right? So up to that time we having only the neutral particle, that one is the proton. So when the beryllium atom is bombarded with the alpha particle, so the neutral radiations are emitted, right? So these radiations are high energy and momentum as that of the photon, right? So these having the high energy and momentum compared to that of the photon. So this neutral radiation is the not possible cases of the protons, right? So for that he given the name as neutron, right? So he given the names of the neutrally radiations or neutrally particles. So those particles given the name as the neutron, right? So how we obtain the neutron means when the nucleus of the beryllium atom is bombarded with the alpha particle, then the radiations are emitted. So those radiations having the energy and momentum more than that of the photon, right? So that up to that case we have only the proton, right? So for that, so this proton having less energy than that of the neutral radiations, so hence this neutral radiations is not the possible cases of the proton, hence they mentioned the name, so that one has the neutron. So new name has given, so that name is called the neutron. And by using the mass spectroscopy, he measured the mass of the neutron, right? So that mass of the neutron is given as mn, right? So the mass of the proton is given as mp. That value is how much? That is 1.00727 u, right? So this mass of the neutron is almost equal to the mass of the proton, right? So mn is equals to 1.0088 1.00866 u. So this is the mass of the neutron. So that mass of the neutron is almost nearer to the mass of the proton, right? So by the Chadwick experiment, so one neutral radiations are emitted, so that neutral radiations given as the name neutron, and that neutron is measured in the mass spectroscopy, and we get the mass of the neutron is mn, that is equals to 1.00866 u, right? So the neutron is the free neutron. So the neutron which is away from the nucleus, that is from the outside the nucleus, so that we call as free neutron, right? So these free neutrons are unstable in nature. The neutrons, here we concluded the extra mass which is present in the deuterium atom is neutron, right? So thus neutron which is present inside the nucleus, right? So if this neutron comes out from the nucleus, then that neutron we call as the free neutron, right? So this free neutron is unstable in nature, right? So it decays into proton, or it converts into electron, or it converts into anti-neutron. So its decay rate is 1000 seconds. So that means if the neutron which outside the nucleus, so the time period of the nucleus is only 1000 seconds, right? So up to 1000 seconds it will be present outside the nucleus, right? So until that it decays into proton, or it decays into electron, or it may decays into anti-neutrino, right? So one more is anti-neutrino. So this one is also the elementary particle, right? So until when the neutron is present inside the nucleus, then only the neutron is stable, right? So understand this one. When the neutron comes out of this nucleus, then the neutron we call as the free neutron, and it is unstable in nature, and it decays into proton, electron, or it may be any antineutrino particle. So until the neutron is present inside the nucleus, then only the neutron is in stable condition, right? So here we need to remember the mass of the proton and the mass of the neutron. So this will helpful while solving the problems, right? So this is about the discovery of the neutrons. So that is about the atomic mass, right? So in the next class we will discuss about the nuclear composition, right? So in the next class we will continue. Thank you.